Hi friends, this is a video tutorial where we will learn about the formulas and mathematical model of three different principles of physics and maths. As we can see our Milky Way galaxy over here, and each planet is on its axis and is performing a rotation on its axis. Now one after another we move each planet: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Neptune, Uranus, Pluto. In astronomy, the explosive event that marked the origin of the universe, also known as Big Bang, is the one at the time in which the entire universe was squeezed into a hot, super-dense state. The Big Bang explosion threw this compact material outwards, producing the expanding universe seen today. Centripetal force is a force that makes a body follow a curved path. It is always directed orthogonal to the velocity of the body toward the instantaneous center of curvature of the path. Centrifugal force represents the effects of inertia that arise in connection with rotation and which are experienced as an outward force away from the center of rotation. Now there are three Kepler's law, but we are implementing two of them. The first one, as you can see here, that all the planets move in elliptical orbits with the sun at their focus, one focus, a line, and the other one, a line joining the planet to the sun, sweeps out equal areas in equal time, which means planets move more slowly at apogees, that is distance, more rapidly at perigees, closeness. So, as here you can get a three-dimensional view of the Milky Way galaxy, which proves the two Kepler laws as mentioned, since all the planets are moving in an elliptical orbit around the sun, where Sun is acting as one focus, and Pluto, being farthest planet and smallest as well, is slowest in covering a complete revolution around the Sun, as compared to Mercury or Venus or Earth, for instance, which are at perigees. Now, let's try to understand what Newton's law of gravitation states and try to understand its formula's significance. As you can see here, the Earth revolves around the Sun and rotates on its own axis as well while revolving. Now let's try and figure out how this happens. Newton's law of universal gravitation states that every point mass in the universe attracts every other point mass with a force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. The Sun attracts every single planet mass by a force F1 pointing along the line intersecting both Sun and planet, and similarly Earth also attracts the Sun with force F2. F1 changes for different planets. The force is proportional to the product of the two masses of the Sun and the Earth, for instance over here, and inversely proportional to the square of the distance between the Sun and the Earth. The Newton's law of universal gravitation formula is F, that is the force of gravitation, is equal to G, mass of the Earth, into mass of the Sun by the distance between their centers and the square of it, where F is the force between the Sun and the Earth, and also called the force of gravitation. G is the gravitational constant, ME is the mass of the Earth, MS is the mass of the Sun, and R is the distance between the center of the masses. Assuming the SI units, F is measured in newtons, mass 1 and mass 2, that is, mass of the Earth and the mass of the Sun, is measured in kilograms. Distance between them is measured in meters, and the constant G is approximately equal to 6.67 into 10 to the power minus 11 Newton meter square per kg square. Newton's law of gravitation resembles Coulomb's law of electrical forces, which is used to calculate the magnitude of electrical force between two charged bodies, but we won't go into that. Now let's talk about the centripetal force and different kind of force which acts on a body while revolving. Talking about the movement of Earth on its axis, here we have an enlarged version of our planet Earth. We see that there are three rows over here, and each is depicting a direction of force and velocity. First one, away from the center, is the centrifugal force. Then next is the direction of the velocity, which is acting towards the direction of revolution on the orbit and this one is the centripetal force. Gravity supplies the necessary centripetal force to hold a planet in orbit around the Sun. Setting the gravity force from the universal law of gravity equal to the required centripetal force yields a description of the orbit. The orbit can be expressed in terms of the acceleration of gravity in the orbit. F gravity is equal to m into g gravity, that is m is equal to m into v square by r, which is the force, actually the centripetal force. The force of gravity in keeping an object in circular motion is an example of centripetal force. Since it acts always perpendicular to the motion, gravity does not do work on the orbiting object if it is in a circular orbit. Centrifugal force is just the negative version of centripetal force since it acts away from the center. So we have finally understood the concept of Kepler's law, Newton's law of gravitation, and the concept of centripetal and centrifugal forces.